In this video we're going to look at how to pass outcome 3, which is the differentiation outcome. This is the biggest outcome in the NAB and you need 11 out of 16 to pass. So I'll do this video in two parts. First question, question 9. Given that y is equal to x to the power 5 take away 3 all over x cubed, where x cannot be 0 because you can't divide by 0, find dy by dx. Now there's a few methods of doing this. You can take x up to negative 3 and put brackets around this. This is not the technique I use, however it is valid and it does work. I split this up into x to the power 5 over x to the cube, x cubed, take away 3 over x cubed, like this. So split it up into two separate fractions, and I think it's much easier to deal with that way. So x to the power 5 over x cubed, take away 3 over x cubed. I can now use my laws of indices. When you're dividing, you subtract, so this goes to x squared, that'll give me a mark. And to get this ready to differentiate, I need to take the x up to the side and make it a negative. So that becomes 3x to negative 3, and that'll get you a mark. Finally, I'm ready to differentiate, so write that down. Dy by dx equals, multiply down by the power and reduce it by 1, so 2x to the power 1, we'll just write that as 2x. Multiply down by the power, that will become a plus 9, and reduce this by 1 to negative 4. That is all you need to do in the NAB. You don't have to rearrange it to 9 over x to the power 4. I would encourage that, but at NAB level, that will get you full marks. Okay, question 10. The curve with equation y equals x squared, take away 5x plus 6 is shown below. Find the gradient of the tangent to the curve at the point 5, 6. So we're looking for the gradient of this line. So to get the gradient of this line, we need to differentiate the curve and then substitute in the x value. So we've been given the equation y equals x squared, take away 5x plus 6. We differentiate this. Write dy by dx will get you a mark to know that you're differentiating. Take the 2 down and reduce it by 1. Differentiate the negative 5x, and that's take away 5. And you differentiate 6, it goes to 0, so that's the second mark to do that. We need a numerical value for this, so we substitute in the x value because we're trying to find the gradient at this point here when x is 5. So if we substitute x is 5 in here, we can get a numerical value for that. So 2 times 5, take away 5, will get you another mark. That comes to 10, take away 5, which is 5. So the gradient of the tangent is 5 at the point 5, 6. So in those two questions, we've got 1, 2, 3, 4, 5, 6, 7, 8 marks.